Hi, this is Bill Barry, the instructor for the differential equations and linear algebra portion of EG 501 for Norwich University. And I wanted to make a short tutorial video today on how to create a parametric plot using PTC Mathcad Prime 3.1. So we're currently in week 2 of our course, and the project that's due at the end of this week involves solving some first order linear differential equations. But the last part of the project, part E, is to create a parametric plot in Mathcad that shows the flight of the golf ball that we're analyzing in this project for both the cases with wind resistance and without wind resistance. So I just wanted to give you an example, a quick example in Mathcad of how to create a parametric plot. So let me share my screen. I'll get my Mathcad up here, and I've prepared this problem. So given that a particle is traveling during the time interval from t equals 0 seconds to 2 seconds, its x and y coordinates are given as a function of time by these two equations. X of t is t cosine of 2t, and y of t is sine of 3t. So what we want to do is create a plot using Mathcad that shows the path of this particle. So this is not unlike what you're being asked to do in the last part of our week 2 project. So the first thing that we'll need to do is in Mathcad, we'll need to define the functions x of t and y of t. So doing that, we'll type x, open parentheses, and t, and that's how you create a function in Mathcad. And then what we want to do is use the assignment operator, which if we type a colon, it'll put the colon equal sign there, and that's the assignment operator, and it's going to assign what we're about to type now. It'll assign that into the function x of t. And here we'll just type t times the cosine, that's a built-in function in Mathcad, the cosine of 2 times t. So that's easy enough. Without attaching any units to arguments in cosine and sine and other trig functions, just note that the assumption in Mathcad is that the angles that the cosine is being taken for is radian. So the default radian, or the default units for trig functions in Mathcad is radian. So just beware of that. So let's define the function y of t. Y of t is just equal to sine of 3 times t. And the parametric plot is going to be relatively easy. There's just one key step that's kind of hard to pick up from the Mathcad tutorials or any Mathcad references that you might have. But over the years, I've sort of come to learn, at least for me, this is the easiest way to create a parametric plot, but also to control the domain that's being plotted in functions. And so what we want to do is actually create what's called a range variable. So I'm going to call our range variable TS. And when I'm reading my Mathcad sheet, I don't see that as TS. I actually read it internally as T's. So what I'm doing is I'm defining a set of values of time that I call T's. And to define this range variable, it's actually going to be a list of times. What we need to define is the first value, which is 0. The second value, which will just be 0 plus whatever we want our time step or our time increment to be. And let's start with, I guess, a relatively not small time increment. So our second time will be 0.1. And remember, we're trying to create this plot from time equals 0 seconds to 2 seconds. So After the dot dot, which Mathcad has automatically put in there, it's recognized that we're trying to define a range variable. We define our last value, which will be 2. So what tease is, what this variable is, it's actually a list of numbers, 0, 0.1, 0.2, 0.3, continuing with a step of 0.1 until it gets to 2. And we'll use that to create our parametric plot. So let's go to plots, insert a plot, and we'll just do a standard XY plot. So it puts the plot in, and make sure that we're doing this below the definition of our functions and our range variable. And then here it's just simple. What we'll do on our y-axis, we want this to be our function y evaluated at the t's that we created. So it's y of ts. And our x-axis is going to be x of ts. And that's it. That's the path of the particle over the first 2 seconds. And if you look at this, you can kind of see the piecewise linear nature of this graph here. It's not really very smooth because our time step wasn't that small. And notice in the extreme, what if I made our time step a half a second instead of 0.1 seconds, right? Then now we're not even really capturing any of the features, or I guess the major features of the path of this particle. So the plot that you get is going to be dependent on the size of your time step. On the other side of that, if I make the time step really small, so if we're plotting every 0.01 seconds instead of every 0.1 seconds, you can see we start to get a smoother and smoother plot. And say we wanted to extend this to 10 seconds, right? We'll just change the end value to 10, and then now we can see there's lots of crazy stuff going on, but that's the path of the particle over 10 seconds. But the assignment was to plot it from 0 to 2 seconds. So there we go. We get this nice parametric plot, and I like creating the range variable TS and using that as the independent variable in our parametric plot, because it really allows us to pretty easily control the start value for time for our plot, the end value, and then also the time step. But just a caveat, this 0.01, this is not the time step, it's actually the second value. So the time step is inferred from the first value that we define 0 and the second value. All right, so hopefully this helps, and I think that you'll be able to create some pretty neat looking parametric plots for our assignment for week 2, following the steps that I've done here. So I'm going to sign off. Thanks, and have a good night.